you've seen number lines many, 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 many times. And we know that they can go up by different amounts. So I could have them go up by ones. So this would be 5. This would be -5. And we know that in between each of these little tick marks, there can be a decimal. So right here is 1, but there's actually numbers in between those. So I can take this number line and I can zoom it in. So now 1 is way over here, and over here we have -1. Now let's say that I wanted you to plot the number 0.5. What that means is basically between 0 and 1, we are breaking this down into 10 parts. So each of these red little tick marks is equal to 0.1. It's equal to 1/10 because I have broken this into 10 pieces. So if I want to plot 0.5 on this, then what I would do, I'd have to go over 5 red tick marks. 1, 2, 3, 4, 5. So I can see by this number line right here that 0.5 is exactly in the middle. 0.5 is the exact same thing as 1/2. That's why it's right in the middle, because it's worth a half. Over here, we have decimals in between the -1 and the 0. So again, we have 10 marks. All those 10 marks represent where the decimals are. So each one of these is 1/10 because I've broke it into 10 pieces. So if I wanted to find -0.5 or -5/10, I could find that over here too. I just need to find it going backwards instead of going forwards like I did before. So this is -1/10 or -0.1. This is -0.2, -0.3, -0.4, and then right here would be -0.5. I'm not going to write all of the numbers in because it's too small and my numbers would be too big to be able to write them all in there, but hopefully you get the idea. So what's pretty cool about this is we can predict where a number is going to be because we know that if it's a higher decimal, it's going to be closer to 1, and if it's a lower decimal, it's going to be closer to 0. Let's say we have something like this, and let's say that we don't have the little red tick marks. I can look at this and I can guess where I think 0.5 is going to be on this number line. So 0.5, we already know that's half. So I just have to kind of judge and see where halfway would be. And I'm going to call this 0.5. And if I want to find -0.5, I'm going to look between -1 and 0, and I'm going to kind of guess, okay, where is the middle? Probably about right there. Now, do I expect you to be perfect? Not at all, because we're just guessing, and we haven't really done that much of this, so if you don't get it completely right, or don't get it exactly in the right spot, that's okay. We're just shooting for as close as possible to the right spot. So this would be -0.5. Now, what if I wanted you to find 0.2? Okay, well, I know that it's positive, so that means that, and it's 0.2, so that means it's pretty small, only 2 out of 10. I have 2/10 here. So that means it's going to be between the 0 and the 0.5. So I know it's going to be kind of close to 0, so like 0.2 is probably like right here. What if I have -0.8? Okay, so 0.8, that's going to be close to 1. So 0.8 is probably going to be about like right there. Now, is it exact? Probably not. Am I going to take the time to measure it all out? Probably not. Could I if I wanted to? Sure. Is that worth doing? No. Because all we're doing is figuring out a general place where the numbers would be. Now, here's the next part of this. Okay, we have seen a number line like this. 0 in the middle, 1 over here, -1 on the other side of the 0. Now, I could take this and I could spin it any way. Now it's going up and down. This one's still worth 1. This one's still worth -1. So look what we can do. To make a coordinate plane, I already have a number line. Boom. All I got to do is make another one that goes up and down. Mind-blowing. So now, basically what I did was I just replicated this line and I put it straight up and down. So this is my x-axis, if you remember, and this is my y-axis. We remember which one's which because the y has a tail that goes down, and the x kind of looks like a man doing jumping jacks, and his arms are going out wide. This is the origin, remember, 0. I'm gonna rewrite it just so it's a little bit easier to see. So this is that spot right there is worth 0 going up and down and left and right. we have a negative 1 over here, a positive 1 over here. If we go up, we are in the positives, so that would be worth 1. And if we go down, we are in the negatives, so that is worth negative 1. So just like before, between 0 and 1, there's decimals. So we can see that I've broken this down into smaller pieces. There's 10 pieces between the 0 and the whole number 1. Number 1, no matter if it's negative or positive, there's going to be 10 tick marks in between there, and each one of those is worth 0.1. So this would be positive 0.1, this would be negative 0.1, this would be positive 0.1, and this would be, right here, would be negative 0.1. Sometimes you will get coordinates that are in decimal form. And so then what you need to do is you need to predict where that might be. Now, I'm going to switch over to the other grid because this one, basically, you know, what's going to happen is all these little tick marks, we're going to extend them up and down so that we can make a grid. But as you can see, it does not look that good because I'm doing it freehand. So we are going to switch over to this lovely grid that I made with a ruler, and I just messed up. Whoops. We're going to switch to this grid. So you can see that right here is the origin. That's the 0 mark. That's where the two axes combine. That's where the two axes meet. Remember, this one is X, and this one is Y. It's got that tail that goes down. This is a guy doing jumping jacks, and his arms are going out, so it's like the side. He's got his arms going out, so you know it's the flat one. You can see that each one of these little tick marks, these are not worth 1, these are worth 0.1. So each one of these is worth 0.1, so it's been broken down into 10 pieces for decimals. And this line that is darkened, that is actually worth 1. So it's kind of like we took this one, so it's kind of like we took this coordinate plane and we zoomed it in to just this part. So it's kind of like I just zoomed it in really close. So now we can see all the little numbers in between the whole numbers. So let's say that we have a problem. So remember, for our coordinates, we start at X and then we go up or down on the Y. So over on the X, up or down on the Y. It's always the order that you have to do it in to get the right point. So let's say that we have 0.6, comma 1. So we're going to go over 0.6 places. So 1, 2, 3, 4, 5, 6. And then we're going to go up one whole number. We're going to call that point A. That point is not actually where the big lines cross. It's because I didn't go all the way over to 1. I only went over 0.6. Now, it can get even more advanced. Let's say we have 0.4, comma 0.5. So that means I'm going to go over 4, and I'm going to go up 5, because those are both positive numbers. So now I'm going to go over 0.4, 1, 2, 3, 4, and I'm going to go up 0.5, 1, 2, 3, 4, 5. And we'll call this B. So you can see that if I was looking at this graph, here's my 1 by 1 square. So on this graph, there's my 1 by 1 square. And these would not line up right where the dark lines connect. Okay, so if I have a grid like this, where I don't have all of those nice grid lines to show me exactly where 0.4 is or 0.6 is, I'm going to have to guess. And this is where it comes in, where it's okay if you're not perfectly on the right spot. We're just trying to get to the closest spot as we can. So in this case, it's asking us to find 0.6, comma 1. So I'm just going to have to judge. Now, I know that 0.6 is really close to 0.5, so that means that it's probably going to be in the middle and then just a little bit over from the middle. So if this looks like the middle to me, 0.6 is probably just like a little bit over here. And then I'm going to go all the way up to 1. So this point, 0.6 comma 1, that is actually going to be right here on this line. And I'm going to label that A. And then I'm going to put in parentheses 0.6 comma 1. Now, you don't have to write this. I just want to write it there so that you remember what it actually is. Okay, and then on the next one, we have 0.4 comma 0.5, and that's going to be B. So before, remember, we had that beautiful grid to show us exactly where 0.5 was and exactly where 0.4 was, but this time we're going to have to guess. So we're going to go over 0.4. Now, I know that 4 is very close to 5, so it's kind of like our 6 situation. I'm going to look at the middle, and I'm going to think, okay, 0.4 is probably like a little bit over from the middle. So maybe like right there. So I went over 0.4 from the 0. And then I'm going to go halfway up this. So 0.5 is probably about right there, and then I'm going to bring those two lines together. So you can see that this dot is in the middle of this square. That's okay. Sometimes it's going to be in the middle of the square. Sometimes you're going to have ones that are not only positive. Sometimes you'll have some that are in the negatives. So it's really important that you follow directions. In this one that we're going to label C, we're going to go over negative 1.5 and then up 1.5. So for this point, I have to follow my X first. I'm going to go over 1, and then remember 0.5 means half. So I'm going to go over 1, and then where I think maybe half is, you can even put a little dash there so you kind of remember. And then I need to go up 1.5, or remember that means 1.5. So I'm going to go up positive 1.5, so I'm going to be going up 1, so I go up to the 1, and then I'm going to go halfway to the 2, so probably like right about there. You know, just kind of use your best judgment. Half's probably about right there. So my dot is actually going to end up right in the middle of the square. That's point C. That's negative 1.5 comma 1.5. So the reason why we use these decimal points when we're finding coordinates is sometimes we'll have a picture and it won't fit perfectly on each exact spot. So like if I had a map here, if I had a map of Michigan, not all the points on my map are going to fall exactly where the lines intersect. So see, like right here, pretend my hand's Michigan, right here would be a point, and that's not where the lines connect. So if I had a point right here, I want you to try to figure out right now, what do you think that point is? What would you call that point? So pause the video if you need to, figure out what is this point. We'll call this point F for Frank. All right, so we need to find our coordinates. So we need to find our X coordinate first. So I'm going to say it's probably 1.9. We went over 1 and then we went over about 0.9 on the x-axis, and then we went down on the y-axis, so that means that we're going into the negatives. And so we went down 1 for sure. So we went down at least 1, and then this mark is pretty close to that 1 line. Like, it's pretty close. So I'm thinking maybe this, so if I draw a line over to the axis, it's kind of like that far down. So I don't know, what do you think? Maybe like 0.2, 0.3? So this point, F, is about at 1.9, comma 1.2. And remember, I almost made a mistake. It's negative 1.2. If I would have not caught that mistake, I would have got it wrong. So I know this is kind of confusing and you might feel kind of frustrated at first, but once you get the hang of it, it's actually really easy. I'm just going to fly through some examples just to show you some more of how to do it. I'm going to draw some random coordinates and I'm going to use little symbols to make it fun. I'm going to draw a little star. And how about we draw a smiley face, a square, how's that? Okay, We're going to find out what each of these points are. So first we're going to start with the star. So the star is going to both be negatives because we had to go negative on the x-axis and we have to go negative on the y-axis. So I went over 1, there's 1.5. If I draw an invisible line down, this would be about half. So it's really close to this 2 line, so I'm going to guess negative 1.8. About. And then how far down did we go? So for our y, we went down at least 1, and then it's kind of close to the 1. It's kind of close to this 1's line. So it's not quite half. Half might be like about right here. So I'm going to say about 0.3 or 0.4. So comma negative 1.3. So that would be where the star's coordinates are. Now let's do the smiley face. We're going to go over, it's about 1.5, 5. And then we went up to at least 2, and then it's like a little bit past the 2, so maybe 2.1. For the square down here, we went over 0. We didn't go over at all. We didn't go positive or negative. It's right on the line, so that means that the x is just 0. How easy is that? Then we went down 2, and probably about halfway down that 2's line, so we'll do negative 2.5. And last but not least, the moon. Start at the origin, remember? We went over to about 2.5, negative 2.6, 2.5, 2.6. It's like a little bit past the half. And then when we went up, it's almost at the 1 line. This is the 1's line. It's almost at that line. So maybe like 1.8 or 1.7, something like that. And so those would be their coordinate locations. Okay, here's the first assignment you're going to get. You have a map of the United States, and you're going to have to plot different points on it based on cities and different attractions that are in the United States. So the first one that we have is Richland, Michigan. So it says Richland, Michigan is located at about 0.7, 0.4. Find this point and label it R. So I'm going to start at the origin as usual. I'm going to go over 0.7. So what's nice about this map is that all of these points are the little lines. And the gray lines here that are bolded, those are where 1 is. So this is 1 right here, this is 2 right here, and it goes the same up. So there's 10 little boxes here before you get to 1, and there's 10 more before you get to 2. So each of these blue lines is worth 0.1. So if we're looking for Richland, it says it's 0.7. So here's my 1. I'm just going to go over 7 blue lines, so going on the x-axis first. So 1, 2, 3, 4, 5, 6, 7. I'm going to put my finger there to remember where 7 is. And then it says I need to go up 4 because this is positive. It doesn't have the negative sign. So I need to go up 0.4. So now remember, each one of these blue lines is worth 0.1. So this is 1, 2, 3, 4. Now what I need to do is I need to connect those lines together. So all you have to do is just bring your fingers together. So right there is where my fingers come together. So Richland is about right there. And then it tells me to label it R. So I'm going to put the letter R. And the next one tells me that Disneyland is located in Anaheim, California. It is at negative 1.2, comma, negative 0.1. Draw a Mickey head at this point. All right, so we're going to look, start at the origin. It tells me to go negative 1.2, so negative 1, and then over 2 of the little blue lines. So that's where I go on my x-axis. Now I'm going to go on my y-axis, negative 0.1. Negative 0.1. So I'm at 1, and now I need to go down just, I'm at negative 1.2, and I just need to go down 1/10. So right here is where Disneyland is. And I'm just going to draw a little Mickey. How cute. Now this is going to be one of your assignments. I'm going to have a lot of different cities and attractions that you need to find. And I will have an answer key, of course, and then I will post that on the slide. And then I'm expecting you to do that. So if you have any questions, please, please, please let me know. Alright guys, so for this one, I drew a map of Michigan. Yes, I did trace it. And I labeled different cities in Michigan. And we're going to use the grid that I placed on top of it to find out where these cities are located. So let's pretend this is a map, and the map has a grid because you need to figure out where you need to go. And we're going to see where those points are on the grid. Alright, so we're going to start off with Mackinac Island. We got to follow the XY pattern to figure out what the coordinates of Mackinac Island is on this map here. The origin is right here. I realize that it just looks like a dot, but that is the origin. This is 0 on the x-axis, 0 on the y-axis. Remember, this is the x, this is the y. X goes across, y goes up and down. You gotta do x first. So, if I'm looking at where Mackinac Island is, it's very close to the y line. So I didn't really go over very far on the x line. I only went over maybe 0.1. So I'm gonna put 0.1. And then how far did we go up? It looks like went up exactly 2. So the coordinates for Mackinac Island on this map would be 0.1, 2. So see, it's really close to that line. So it's almost at 0. It's probably just at 0.1. Okay, Traverse City would be next. The origin is right here. And Traverse City is on this side, so it's going to be in the negatives for the x-axis. So for our x, Traverse City doesn't go all the way over to our -1 line. It's like if I drew an imaginary line in the middle for where 0.5 would be, I would imagine 0.5 is like about right there probably. If we draw an imaginary line up, that's probably where 0.5 is. So maybe 0.6, 0.7. I'm going to guess like 0.7. So remember, it's negative 0.7. It's not all the way to that 1. Make sure you write the negative or you'll get it wrong. And then how far did we go up? So it's actually past the 1, just a little bit past that 1. So maybe 0.1, 0.2. Oops. That's how easy it is to mess up. 1.2. So to get Traverse City on this map, we went over negative 0.7 and we went up 1.2 spaces. Richland is about right there, so we're going to look on here. So here's the origin. I have to go left or right first on the x-axis. So here's Richland. How far did we go over? Almost half. It's almost right in the middle of that, actually. It's kind of interesting. So we'll say we went over negative 0.5. It's about right in the middle. And then how far did we go down? It actually looks like it landed right on the line for -1, so it would be -1 for our x-axis. So Richland is half a square over and then a whole square down from the origin. Next, we're going to do my hometown, Marcellus. It's a little tiny town, a little bit bigger than Richland, kind of the same vibe as Richland. Way down here, this is Marcellus. So to find the location of Marcellus on this map, we need to figure out how far over from the origin it is first on the x-axis. So Marcellus is a little bit farther west than Richland. So I don't know, let's say like 0.6, 0.7 probably. So negative 0.7, let's say. Remember, we're just trying to get our best guess because we don't have the pretty little grid. And let's say let's see how far down we go. So here's my origin, and then let's see how far we have to go down for Marcellus. So I went down 1 whole square, and then Marcellus goes to about right there on the line between 1 and 2, between -1 and -2. So what do you think? Maybe this is probably about half. So this would be about like -1.3 maybe, -1.4. Make sure you put that negative sign in there. So this would be the approximate coordinates for Marcellus. So if none of these dots were on here, and I gave you these locations, you should be able to plot where the places are on the map. So this is going to be one of your assignments for this week. We already did some of the cities. You're going to have to tell me where all of the cities are on this map. So hopefully you watched the video, and hint, hint, I already gave you 4 answers, so lucky you. But that's one of your assignments. I want you to tell me where all of these cities are located on the map.